Hi everyone, welcome to our lesson on the real number system. You should have received this real number system handout in class yesterday, but if you did not receive the handout, please email me and I can email you a copy and you can complete it at home if you were not in class. So what we're going to talk about over the next couple days is just real basics. What are the different types of numbers? And you might say, well, numbers are numbers, but when we get to algebra, we have a couple different variations and things that we're going to deal with. All of these are part of the real number system. So there is a symbol for real numbers, and real numbers encompass everything that you see below. We see irrational numbers, rational, integers, whole numbers, and natural numbers. So real numbers are kind of made up of these two different subsets, and I usually like to start with the most basic, what you would learn when you were first learning to count, and we consider those to be natural numbers. So the abbreviation for natural numbers is an N with a second line through it, and natural numbers are something that we consider our counting numbers. Okay, so 1, 2, 3, 4, and so on. So those numbers are all part of our natural number subset. As we go a step further, whole numbers is one students are usually most familiar with. So we use a W to represent whole numbers, which makes sense. And whole numbers include the natural numbers and one more. That one additional number is 0. Okay, so our whole numbers would be considered 0, and then 1, 2, 3, and so on. So our natural numbers are part of our whole number group, plus we add in the number 0 when we consider whole numbers. Moving further up the line, we have integers. All right, our integers, we use a little bit of a different letter. We actually use the letter Z to represent integers. And those numbers are the positive whole numbers, so the whole numbers, and their opposites. Which would encompass the negative numbers as well. So I'm going to put that here in parentheses. So what I mean by opposites is we have these positive whole numbers, but we also have their opposites, which would be -2, -1, 0, 1, 2, and so on. Okay? So those are our three subsets. And then we get to rational numbers. And you'll see a definition here for rational numbers. All fractions and decimals that end or have a pattern. So rational numbers, we actually use the letter Q because the letter R is used to represent the real number system. And it could be anything in fraction or decimal form. So something like 1/2, something like -6/7, something like 2.5, something like 5/3. Any of these fractions or decimals that end are part of the rational number subgroup. Okay? If we go over to the exact opposite, you will notice that we have a different definition. Decimals that never end and have no pattern. Think mumbo jumbo numbers. So these numbers are things that have no end. We use the letter I, so it's a little bit more of a logical symbol for irrational numbers. And there's always one big one that I'm usually able to get students to guess, and that would be pi. All right? For those of you familiar with that, 3.14159, but there are more decimals beyond the 159 in the symbol pi. There's also square roots that don't have an end. So a square root like 2, if you were to type that in a calculator, you would get a decimal that goes on and on forever and never repeats. That makes it irrational. If you would have something like the square root of 10, same idea. We get something that goes on and on forever and never repeats. So what we want to try and do is put these numbers at the bottom in their subgroups. Now please know how this chart works. You want to identify the most specific category that a number can belong to. So if I gave you the number 1, it would be part of the natural numbers, but it would also be a whole number, an integer, a rational number, and a real number. So on this side, the chart works kind of in an upward direction. So I'm going to put an arrow on here. All right. So if it's part of the natural numbers, it's everything else above it, except for irrational. If it's a whole number, it's everything else above that except for irrational. Now, if it's irrational, it has 2 classifications. It would be irrational and real. Those would be our only 2 options. So if we look at the bottom of this paper, we have some directions here. You are asked to name all of the sets of numbers to which each number belongs. So you need to think its most specific category first, and then work your way up the chart. And the easiest thing to do here would be to just write the letters, but if you are a little confused with that, you can just write the words of each group. So the number 30, it's a basic counting number. It would be a natural number. All right, so this means it is natural, and it is also everything else above it. So I have to include whole numbers, integers, rational numbers, that's the Q, and real. So if it's a natural number, it actually has 5 classifications, which is a little crazy, but it really belongs to all of those groups. The same idea with number 2. You have the number -11, okay? Well, think about where we put negative numbers. Negative numbers were part of this integer group. So its most specific classification would be an integer. I'm going to put that symbol for integer. And then everything else above it would fall into that category. So you would have rational numbers, and you would also have real. Okay. Number 3 is 5 4/7. As soon as you see that fraction, it should jump out at you that there's a fraction. If there's a fraction, the only place I can go is the rational number category. So it is rational, but please make sure that you note all of these are also part of the real number system. So you always want that letter R as part of your answer. Okay. The square root of 21. If you have a calculator, take a moment, and if you type in the square root of 21, you will notice that that is a decimal that does not repeat, it does not end, it falls into our irrational category, which gives it 2 classifications, irrational and real. For number 5, we have similar idea. We have that number 0. Well, think about where we first put 0. It went into that whole number group, which means it belongs to the integers, it belongs to the rational numbers, and it belongs to the real numbers as well. Okay. Now, number 6 and number 7, I want you to be careful. You need to simplify. If things are written in an order like this, you have the negative square root of 9. Well, the square root of 9 is actually equal to -3. So, if you consider the number -3 as the option you're looking for, or the number you're looking for, you will then place it in the integer category. If you did not simplify, you may have thought it's a square root, it's irrational. Well, you have to make sure that you simplify these square roots to their most specific form so we can classify it correctly. So we will classify it as an integer, and again, the values or terms above that, rational and real. Okay. Number 7, same thing. If you take 6 divided by 3, this might look like a fraction right now, but if you take 6 divided by 3, it comes out to a nice even number. It equals 2. So that means it belongs to the natural group, whole numbers, integers, rational, and real. 5 classifications, even though it initially looked like a fraction. Okay, number 8, pi. That should be a nice easy one. We actually placed pi in the irrational number box, so that makes pi an irrational number and a real number. And then last but not least, number 9, you have 5.3 with a bar over it. Okay, remember that this bar indicates that this decimal repeats. Okay, if it is a repeating decimal, repeating decimals belong in the rational numbers group. It has a pattern. So if it's a repeating decimal, maybe I should add that to this list here, you would get 5.3 repeating. That's a rational number. So at the bottom, I am going to include this as the rational number group in the most specific form, and then working my way up the chart, this would also be a real number. As you're working through this, you could pause the video at any time to kind of fill this in. And once this is done, I would encourage you to watch the second video for the back side of this worksheet, where I explain a little bit more about organizing the real number system here. Have a good day.